All right, so system of equations and 3 variables. Oops, I'm still in red. Oh, we don't want to be in red no more. All right, so if I was going to solve the following system, does anyone have a clue what I'd do to solve this system of three variables? Anyone have a clue what I do? Let's name this equation 1, equation 2, and equation 3 just to make your lives easier. Start with the first two. So just use these two. I mean, that's not a bad idea because here you can get rid of something, right? Because here I could do something, add something, and probably get rid of at least one of these variables. But notice here, do I know what one of these answers is? Do I know what one of the answers is? I'm looking for what is x, because here I want a triplet, right? I want an x, I want a y, and a z. Yeah. I know 3 gives me z is 3, right? And so I can easily just plug in, so I can just plug that in up here, right? Up into 2. So I have y plus 2 times 3 equals 5 from equation 2. Because I know what I know this is, and then y equals, we move over the 6, I'll get minus 1, so this is minus 1, so you can put that in. And then I can go to equation 1, I have x minus 2 of minus 1 minus the 3 equals 1. And so here I have x is equal to 2. You just solve that out, and I get a 2 in here. And so our goal is, if I can get the system to look like this, I can just back substitute. So here I'm just back substitution here, and then back substituting back into here. And so, yeah, so once I know what one of the answer is, and so we're going to try to get our equations to look this way, right? We're going to try to get it to look this way. And so that's kind of going to be our goal. We're going to do 1, 2, 3 of them, and then I'm going to teach you I'm going to teach you, it's the same method, but just a lot cleaner, kind of like substitution, or not, what am I thinking? Synthetic division, kind of like how synthetic division does the same thing as long division, just faster. Well, we'll teach you that here, but we got to do it the long way 3 times. And so let's just get through it. All right, so these operations do not change the solution of the system. So if give equivalent systems, that means they have the same solution. So if I swap one rule for another, right, it gives me the same thing. So if I moved here, if I did 1, 2, 3, right? So if I have equation 1, 2, and 3, if I just move this equation up to position 2 and move this from position 2 down to position 3, right? If I wrote this as x minus 2y minus plus z, was the 1, 3x plus 2y minus 5z, just quickly, equals 3. And then x plus 2y minus z equals 13. Notice here, if I just switch the positions here, this, whatever would solve this, would also solve this. I mean, I haven't really done anything. I just move stuff around, okay? But notice if I also multiply one of the equations by non-zero constants, if I multiply this by 2, so make this 2, make this a 4, make this a 6, make this a 2, that's the same equation, right? It's the exact same equation. Now, so this is just moving stuff around. This is multiplying by non-zero constants, not all that. The only one that may seem a little bit strange is I can add a non-zero multiple of one equation to another. And so here, let me just kind of, whoa, I'm on the wrong layer. Of course I'm on the wrong layer. Why'd I ever write on the right layer? Why start now, right? Oh boy. Here we go. So notice here that here, if I have x minus 2y plus 3z equals to 1, notice if I add to this side, if I add 13 to this side, I can add 13 to this side, right? So if I add 13 over here, I can add 13 to over here. Everyone buys that's I just switched the last two for that one, yeah. Okay. And so here, add 13 to this side, I can add 13 to this side. But do I know what 13 is? Yeah, I know what 13 is this. 13 is equal to this. And so instead of writing 13 here, I'm going to write plus the quantity of x plus 2y minus z, right? And so here I've added 13 here. I've added 13 here, but the 13 I'm adding here, I'm writing in this form since they're equivalent. So that which allows me to add rows, add things to both sides of an equation, still keep it the same. So that's why. All right, so now that we've kind of shown you why all these things work, let's actually do it to solve the system. So what's my goal here? My goal here, I'm sorry, I'm writing stuff that I'm erasing because I want to explain it to you, but you don't necessarily have to have it written down. Maybe I should make room for it on the notes. I just know this takes a couple steps to crunch through. So what am I going to do here? I'm going to show you each step very, very clearly. And then we're going to let me show you the steps. So the first thing I want this to look like this. So the second I get it to look like this, I can solve it because I just back substitute up, right? I say z equals 3, plug that in here, then I'll get an answer for y, and then I'll have an answer for y and z, plug it into here, and I'll get an answer for x. So we want this to look like this. And so in order to do that, we want to get rid of this x here. We want to get rid of, and so we'll just start there. We'll just do one very small step at a time. We're going to get rid of this x. So how would I get rid of that x? Well, I'm going to just take equation 2 and minus equation 1 from it, because I'm allowed to do that, right? Add a non-zero multiple of equation to another. So I'm just adding -1 of equation 1 to this one. So equation 2 is x plus 2y minus z is equal to 13. That's equation 2. I'm going to minus from it equation 1. It's something I'm allowed to do. X minus 2y. Oh, yes, minus 2y minus plus 3z equal to 1. So I'm going to minus this all the way across, right? So here I'll have x minus x. In fact, let's just move in our negative sign to make our lives easier. Okay, let's just move in the negative sign to make the lives easier. So it's be minus x plus y minus 3y minus 1. Okay. So here I'm taking 2 and adding to it a negative of equation 1. So I get 0, which is my desired goal, plus 4y minus 4z equals 12. Okay, and so I'm going to rewrite my new system. So I'll have x minus 2y plus 3z equals to 1. Here I'm replacing row 2 with 2 times 1 of this, so I get this. So it would be, that's a 4. Sorry, make that look like a 4. And then here I've done nothing to row 3, so I'm going to write it down. Okay. All right, so now I want to get rid of this 3x, right? Because I want this to look like this. And so here I'm going to remove this x, and then I'll remove this y. Basically the steps you do. All right, so I'm going to remove this 3x. And so I'm going to take row 3, and I'm going to add to it a minus 3 times equation 1. And so here we'll have row 3, so it'll be 3x plus 2y minus 5z equals 3. We're going to add to it -3 times this row, so I'll get minus 3x. And then -3 times -2 is plus 6y. And then here, -3 times this will be minus 9z. And then -3 times the 1 will be equal to minus 3. All right, and so now we add this up. Now by design, this is 0. That's what we did by design. This becomes 8y. This is minus 14z. And this is equal to 0. So we rewrite our system again. So we'll have 8. So we didn't do anything to the first two ones. So we just write this down. And then this one is now replaced with this. All right. And so what's the next step I want to do? So I got rid of this. I got rid of the x, got rid of the x. Now I just want to get rid of this y. So I'm going to take row 3. I'm going to minus it out from 2 times row 2. Or yeah, row 2. So here I'll have 8y minus 14, which is my row 3. 2 times this row would be minus 8y plus 8z equals minus 24. We'll add this up. I get nothing here. I get minus 6z here, and I'll get minus 24 here. All right, so I'll go ahead and put a line here. I can delineate something. So let's rewrite our equation. So we have x minus 2y plus 3z, just copying this down from over here, oops, equals 1. Copy this one, it'll be 4y minus 4z equals to 12. And we'll copy this one. We'll have, our new one, which is minus 6z equals to negative 24. Okay. Can you rewrite the first equation again? This one? Which one do you want me to rewrite again? Isn't it 3? All right, let's go back to the questions real quick. Isn't it 3z? 3z. So this is equation 2, and this is negative 1 of equation 1. This is equation 3. This is minus 3 of equation 1. So that's where these numbers come from. This is equation 3, and this is minus 2 of equation 2. That's where I'm getting these from. Okay. Can you rewrite the first equation again from the first rewrite? I think. Oh, no, when I pull this, yeah, I can pull it from, I was just pulling it from one the last time I did it. Yeah, you can rewrite it from here. It's always the same. It's always 1 minus 2z. It's always, I haven't changed it ever. Okay. The first time you changed the set and wrote in x minus 2y plus 3z equals 1. Hold on, let me see. First time you changed the set, you wrote in the first equation. Oh, okay. Yeah, sorry. This is x minus 2y plus 3z. Yeah, sometimes when the tablet writing's not as amazing as you think it should be. You get used to it, but my handwriting's still bad. Sorry about that. Okay, so here, this equation 1 always says equation 1. We never really altered it. So here, can I figure out what z is? Does anyone have a clue what z is now? So what's z in this case? Yeah, it should be 4, right? Because it's negative 6 divided by negative 24 just gives me 4. If z is 4, I can use equation 2 to find out what y is. So I have 4y minus 4 times 4 equals 12. And so here, I can also rewrite this to be, I can just divide out 4 everywhere. This is the same as y equals 4 times 3. So here I've divided a 4, divided a 4, divided a 4. Since there's a 4, 4, and a 4 here, it just makes life easier. So I get y equals to 7. You don't have to divide out the 4. You'll get the same answer. You get y equals 7. And then I'm going to use equation 1 to figure out what x is. So I have x minus 2 times 7 plus 3 times 4 equals 1. And if I solve that through, I'll get x is equal to 3. And so here's my solution of 3, 7, and 4. Okay. So once I get this one, I just go ahead and find out, once you have it in this form, you figure out what z is. Then you're going to take the second equation. Since you know what z is, you plug it in. You can figure out what y is. And then you can take the first equation, since you know what z and y are. You can plug it in and figure out what x is. Okay, and that's just basically how you do this. We'll do this like 18, or we'll do this like maybe not, 10 more times before we're done. We're going to do it the long way 3 times, and then we'll do it the shorter way. It's not that much shorter, but it is shorter. It's just easier to track stuff, in my opinion. So I'll leave this up for 1 second, take a drink, and and then I will do the next page. All right. Let's go ahead and zoom on in. All right, so here, a linear system can have a bunch of solutions. So let's see how well I can draw graphically today. All right, so notice that, does anyone know what this is? So if I had some ax plus some by equal to some c, this is a line, right? Does anyone know what ax plus if I could write ax plus by plus cz equal to d. Does anyone know what this is? Anyone know what this is? They can put it in chat if they do. It's okay if you don't. I'm just curious if anyone does. What's ax plus by plus cz? Or another case, this maps what? Does anyone know what this maps? I don't know. Okay. These are, oh man, say I'm on the wrong layer again. These are planes. So x plus y plus z, oops, whoa, way too far, go back. X plus y plus z, so these are planes, and so these are 3D objects. So I'll actually need to draw on my z-axis here. I don't have a z-axis. And so for anyone who's done 3D drawing, this is your x-axis, this is your y-axis, so this is your xy plane right here. This is your z-axis. This is how you do 3D drawings. Okay, and so here we have something with exactly one solution. So the same thing here for any number of solutions for linear. The number of solutions for any size of system, right? You can have one solution, no solution, infinite solution. So in last time we had lines that crossed, we had lines that were parallel, and then we had lines that were the same, right? For the 1D case. And here in the 3D case, we have planes, right? And so here I can just kind of draw roughly an idea of a plane. Okay. And then here, I'm going to draw a different thing to kind of help me. So I'll have another plane coming out this way. Another one coming out this way. We'll have the back part of it, the other back part of it. And so here it all intersects at a point. It's kind of hard to see. So these would come in from here. So roughly you can have them all intersect at a point. So if I have, so 3 planes, if I have 3 of them, they may intersect at one point. Another thing that could happen is I can have a plane right here, kind of in this space. I can have another plane right here in this space, and another plane like here in this space, and they're all just kind of parallel to each other, so I have no solutions. Or in this case, we can have, let's see if I can draw this without being completely insane about it. I could have 3 planes that kind of intersect here at a line. And so they all intersect here at some line. So here we have them all here at a line. And so here, I know my drawings aren't amazing, but here we can have 3 planes that intersect at a point. We can have planes that don't intersect, and they all can intersect the line. long story short, you can have exactly one solution, no solution, or many solutions. And so let's solve this system, and we'll see what happens when we try solving it. All right, so let's do this slowly. And so I'm going to start showing what I call my shorthand notation for everything. So we're going to call this 1, 2, and 3. And the reason I'm doing the shorthand notation, it makes it easier for me to do. It makes it, it's less mess on your paper, so you get actually less distracted by all of it. And it's faster. And so here, I'm going to take equation 2, and I'm going to minus from it 2 times equation 1, and I'm going to put that into equation 2. So I'm going to take equation 2, minus 2 times equation 1. I'm going to put that as my new equation 2. It's kind of exactly what we did last time. Here I'm taking 2 minus 1 and making that my equation 2, right? So I took this equation minus this equation, and then I put it back into this equation. That's what I did here, right? So I'm adding, and that's adding a non-zero multiple of one equation to another. So here I'm adding a -1 of this equation to this equation. So, but what I'm going to shorthand write is just this. I'm going to take -2 of this one and add it to this one. So I'm just using this, okay? And then I'm going to do it slightly in my head as a little bit of mental math, but I'll show you how to do that as well. So here, the first one, I didn't change anything, so I just write it down. The third one, I didn't change anything, so I just write it down. Okay, this one I've changed. And so I'm taking, by design, I want to zero this out, because remember what our goal is? Put a 0 here, put a 0 here, and then put a 0 here, and then we can solve, okay? So this is what we're going to do. So here we take these x. So we're going to take -2 of this x and add it to this. So -2x plus 2x is 0, right? That's by design. -2y plus, so -2 times 2y would be -4y. Add that to 2y, I get -2y. -2 times -2z will give me +4z. 4z plus -z gives me +3z. And then I'll have -2 added to 6, and that'll give me 4. Okay. And so instead of writing it out as an extra step and all this other stuff, you just do -2 times this, add to this. So 1 times -2 gives me 0. Oops, 0. This gives me -4, add to 2 gives me -2. This gives me +4, add to -1, that gives me +3. This gives me -2, add it to 6, and I get 4. Okay. So the next step is I want to do is make this a 0. And so in order to do that, I'm going to take -3 of this row and add it to this row, because I want this to cancel this out. Okay. And always do it in this order. Always get rid of this. Always get rid of this one. So do this one first, do this one second, and do this one third. Always do it in that order. Because if you do anything in any other order, it just doesn't work out. Trust me on this, because you'll start moving stuff around, and then you're going to put stuff back where you removed it. And what we call in math alphabet soup, where you're just swirling around letters and never get anywhere. Okay. So let's do that next. So here, the first 2 rows are the same. So I don't change them at all. So I have x plus 2y minus 2z equals 1. I didn't change this row, so it's -2y plus 3z is equal to 4. Here, I'm taking -3 of this row. So -3 of this would be -3 plus the +3 equals 0 by design. That's why we took the -3. -3 times this is -6. -6 plus the 4 gives me -2y. Here, I have, this becomes +6, right? +6 minus 3 would give me -3 gives me +3z, and then -3 plus -3 plus the 5 will give me +2. Okay. All right, then the next thing is I want to get rid of this. So I'm going to just take I'm going to take -1 of this row, add it to this row, and that should get rid of this. So I didn't do anything for the first two rows, so I'm going to write those down. Choose 2y minus 2z equals to 1. Don't worry. For those who are taking this class remotely or online, which includes the current class I'm talking to, I'm going to reuse these videos, so sometimes I talk to future students. I'm going to show you how to do this in the calculator. I just am. And so you can always check your work. All right, so I copied down the first two rows. So if I take -1 of this row to this row, this becomes +2. Plus 2 is 0. So that's 0, 0 by design. And then I'll have -3 plus +3 is 0. So that's a little bit interesting. And then I'll have -4 plus 2 equals -2. Well, once here, remember when we, in the last chapter, if we had 0 equals something that wasn't 0, we were done. It's no solution. Again, this one's no solution. Okay? So this one's no solution. All right, so I'll let you write that down. Let me do something super fast. Wolfram alpha system of equations. Woohoo. All right. So for those who are wondering, how do I type this happiness into a computer? So let's show you how to do that as you guys finish writing this down. So we go to our class calculator, which is Wolfram Alpha. And then we just type in system of equations. And then it brings up this little thing here. Please type in your equations. And so here we have equation 1. And so we'll have x plus 2y minus 2z equals 1. Here we have equation 2. Go ahead and type that in. We'll have 2x plus 2y minus z equals 6. And then here we have 3x plus 4y minus 3z equals 5. We'll just hit compute. And it should, hopefully. All right, so here's our 3, and it says no solution, which is good. All right, let's just do it. So let's solve this one. And here I think I get, let's go back to the first one. Let's type that one in real quick, just so you can see one that works out normally. So here I have x. Let's just and then 1. All right, this is 13 minus c plus 2y plus x, and then we have 3x plus 2y minus 5z equals 5z equals 3. Okay, and we'll just have that compute for us. Bum, 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 bum. And we should get 3, 7, and 4, as we got. Okay. So this is just how you type it in the computer. As just type system of equation, just hit compute, right? It assumes you want a system of 3 equations, which is correct. Can I see example 4 again? All right, so let's just look at that for a second, and then we are going to do the last one. And this last one's going to take a second because I have to explain some things, and so we'll get to it. In fact, as you guys copy that down, I will save time, and then I will pre-write this one in because I'll have x all right, and the next one is 2x plus y plus 4z. I got 2 z's there. is 2. And then this would be 8 minus 2, oops, hi, 8 minus 2z plus 4, and I think that's a 2. We hit compute. Let's see if I got this typed in right. Yahoo. Okay. Ta-da. All right, so here we're going to type this happiness in. So here we type this in, and we notice here we get, we're going to get something that looks vaguely like this. And so given an x, so here we have infinite solutions. So given any x, we're going to have a y and a z that we can compute from that. And let me show you how I do it. And then your computer does it. I mean, this one does it slightly differently. And then we're going to look and see how your online homework wants it done. Okay, so I can show you exactly the way it wants it done. All right, so I'm going to go a little bit fast on this one since I'm going to teach you a better method in the next section, okay? And so instead of doing this one at a time, I'm going to do, so here I want to make this 0 and this 0, and you can do these simultaneously. Actually, that's perfectly fine because I'm going to only mess with this equation and only mess with this equation. So the first one I never mess with, so it's a minus y plus 5z equals to minus 2, okay? For the second equation, I'm adding negative 2 of this equation to this one to get rid of this x. Remember, that's our goal, to get rid of this x and get rid of this x. And you can do these both at the same time. So we're going to do them both at the same time, just so we don't have to write so much. Okay, so negative 2 times this gives us 0. Negative 2 here gives us minus 3 plus 1 would be minus 2y. Oh, negative 2. Hold on. All right, first of all, I'm on the wrong layer. Second of all, I can't seem to be doing math. Negative 2 times negative y is positive 2 plus a y is positive 3. Negative 2 times the 5 is negative 10 plus 4 gives us minus 6. Let's see. Negative 2 times the negative 2 gives us positive 4 plus 2 would give us, oops, my z crashed into my 6. Gives us 6. Negative 2 times this gives us positive 4 plus 2 gives us 6. All right, we can do the same thing here. Negative 2 times this gives us negative 2. We add it to here, we get 0 as by design. Negative 2 times this will give us will give us 6. So negative 2y, so it gives positive 2y plus 2 plus 4 gives us 6y. I can speak today. Here, this gives us negative 10 minus 2 would be minus 12z. And then negative 2 is positive 4. 4 plus 8 is 12. Okay. All right. So we got a 0 here, a 0 here. Now we want a 0 here. So we're just going to take minus 2 of this row to add it to this row to get that. And so what do I get here? I'll have x minus y plus 5z. I didn't change that one at all. Is equal to minus 2. Didn't change the second row, so I'll write that one down. It's equal to 6. And then here, so negative 2 times this would be minus 6 plus the 6 is 0 by design. Negative 2 here would be positive 12 plus 12, which is 0 here. That's not by design. And then here, negative this equals this is 0. And so here, I get 0 equals 0. So remember what that means last time? That was infinitely many solutions. Same thing here. So that means z can be whatever, right? We haven't established what z is at all. So I'm going to just let z equal to t. That's what I do. I'm going to figure out what your book does, and I'll write it in the space next to us, right? But if z equals t, then I can say that 3y minus 6t is equal to 6. And if I solve that for y, I get y is equal to 2 plus 2t. So here I'm letting z equal to t. Then I get y equals this, and then once I have, and then we can figure out what x is. So notice here, I'm just going back like I always do. But instead of plugging in z equal to a number, I'm going to have it be a variable t. And then here I solve this one, and so here minus What is y? It's 2 plus 2t. And I'm going to hit minus, minus or plus 5. Plus 5 times what z is, so 5 times t, because that's what z is equal to minus 2. Solve this for x. We'll get x is equal to this -2 and this -2 cancels, and then I get minus 2, so I'm just going to be left with minus 3t. Okay? And so my answer here is -3t, 2 plus 2t, and then t. So that's how I was taught to do it. Okay, that's how I was taught to do it. So let's see what your book wants. Okay, so let's go ahead and put a star here. That means why I'm going to cut the happy video, because I cannot show the book and